welcome. My name is Brendan, and I'm a Blue Coat. I'm also a teacher at Science North. And what I do on a day-to-day basis is working with teachers and helping to share my love of science with all of you. And that is really what we're doing today. Is we're going to take that same love of science and we're going to share it with you. Going to give you some ideas and work through a little bit of PD that talks about inquiry-based learning. So this is part of a series of 3 videos that we're releasing. This is going to be a primary level video talking to that K to 3 level and giving you some topics and introduction and some ideas for that grade. We're also going to be releasing a junior video and an intermediate video in the weeks to come as well. So really the goal of this activity and the goal of this video is to introduce you into inquiry-based learning, as well as a couple of resources and tools and ideas and projects, however you want to call it, for you to be able to do this with your students as well. So these are weird and challenging and difficult times, and really what we want is to be able to give you some ideas and things that you can do with your students as well. There are 3 parts to this video that we're going to be looking at for the primary teacher PD sessions. The first part that we're going to do is look at inquiry-based learning. We're just going to have a bit of a discussion about what that is. Then we're going to look at a sample inquiry activity. So it's an activity that we really enjoy at Science North and one we use fairly often. We're going to look at that activity. I'm going to walk you through those steps together to show how inquiry can be done with an actual example. And then there's going to, at the last part, the last thing is that we're going to show you an at-home inquiry challenge. So this is a challenge that we're going to pose to you, the teachers, and more importantly, maybe to your students, to try to come up with a solution to this challenge. And we want you to share that with us. So that's what we're looking at today. 3 parts. And let's start with part number 1. All right, here we go. On to the first part. What is inquiry-based learning? This is a topic that's floating around all over the place. And I think it's valid that it is. It's a really great learning style, and it's the one that we use a lot at Science North. So what we're going to talk about today is how we use it at Science North and what it means to us. You may have a different definition, and there's probably lots of other definitions, but we've looked into it. We use this model quite extensively, and really I want to share that with you today as to what that is. So inquiry-based learning is what Science North is all about. It's that hands-on, interactive, engaging, fun learning style where we're not telling you what to do, but rather we're giving you opportunities to learn on your own. So it is truly inquiry-based learning. Is that learning by doing. It's using hands-on activities, demonstrations, interactions to strengthen that knowledge. We always think of it in the sense that if you're playing and you're playing in something that has that science background or that math background or some kind of background, you're going to, in playing, learn through that as well. So we really, at Science North, we encourage students to ask questions. We want them to be curious, and we want them to discover what's around them. We have this great open science center with so many things to see and touch and feel and smell, and we want students to be able to learn about that and be curious and explore. And that is that spirit of inquiry-based learning that we're looking for. So if we're looking at strictly the definition of inquiry-based learning, it's self-directed learning where the responsibility is on the learner to discover new knowledge. So the learner being your students, and new knowledge being provided by you, but also by all kinds of sources. And it's what we're really pushing as well is that it emphasizes active participation. This isn't just telling your students to go read a book. It's getting them engaged and involved. And it's getting them involved in a challenge or a topic or something that interests them. And then by finding something that really interests them and engages them, well, your students are going to be more interested in diving into that learning. So why use inquiry-based learning? Why is that something we love at Science North? Well, quite frankly, we're biased. We're all scientists, and inquiry-based learning is all about the scientific process. It's the same process that scientists use for building their own knowledge, and it transitions really well to everyday life. Because science is not knowing the answer to things. If we knew the answer to everything, science wouldn't really be that great a thing. Science North wouldn't need to be here. But that is what the beauty of science is, that there are so many problems, there's so many unknowns in this world that we don't know anything about, and being able to come up with solutions and clever responses to that, that is learning, and that is learning like a science, like a scientist. And that is what inquiry-based learning is all about. It's that authentic scientific discovery process that takes that ability to communicate and think like a scientist, and really use it and use that idea to learn. So the reason I say that and the reason I talk about that is that there's this process. There is a 5-step process that inquiry-based learning uses that is the similar process to what a scientist uses. So we're going to look at that. We're going to take a minute to look at that a little later on, actually. But I just also want to talk about the fact that this is the perfect time to use inquiry-based learning. We're all at home and we have access to technology. And technology is something that allows students to follow that inquiry process using self-guided projects. And that's the other thing. If you don't have access to technology, there's a whole world around us that you can learn from. You can learn just by going for a walk, reading books, hearing stories, talking to someone who may know something about that. There's so many ways to learn that aren't strictly tied into that conventional learning that we know. We can learn from everything around us. And you can learn at your own pace. So that's why during this quarantine and during this self-isolation, that we really want to push inquiry-based learning is that it could be done at home at a student's pace and in something that interests them. And that interest is what's going to really grab them and make them want to learn more. And it also builds in doing that lots of really great long-term skills. Learning how to identify a problem, learning how to ask questions, carrying out experiments, understanding data, understanding the world around you, and being able to share what you learn. Those are real-world skills that apply to inquiry-based learning, but apply to everything else that you do as well. So I mentioned the steps earlier. What are those steps? What do you need for inquiry-based learning? Well, really, there are 5 phases to it, to inquiry-based learning that form the inquiry cycle. And I call it a cycle because inquiry-based learning is not a linear thing. There are 5 steps, yes, but you can start at step 1, jump to 3, come back to 4, and then restart at 1 and then continue forward. There's no real need to have this linear structure. But rather it's a framework that you can always explore and look at, because the learning is changing. It's always growing and evolving, and it's ever changing, and that's the beauty of it, is that it's never done. So I'm going to take a minute. I'm going to show you an image, and we'll talk about what those 5 phases are. All right, here we go. So this is that inquiry-based cycle that I was talking about and the 5 phases that go into it. So we have observe, brainstorm, create, improve, and share. And it is a cycle because we are fluctuating between those and we're never really stuck on one of those different parts. So today, after this first section of the video where we talk about what these are, I'm going to take these 5 phases and do 2 inquiry-based projects with you, really. One where we're going to guide it and kind of come up with a solution together, and one where it's going to be a challenge for you to do with your students. And that doesn't mean you can't do the other one with your students as well, but it's just giving you 2 different options. All right, back to me. So the first of those parts of the cycle is the observe. So the observe step is really about starting to understand what the topic is and introducing a challenge, introducing a topic, introducing a learning goal that really is there to stimulate curiosity about the topic, and starting to prompt that interest from the students. So a really great way, especially at the primary level, that you can involve this is to introduce something that the students have some prior learning about, where they can make those connections and go, oh, wait a minute, I know something about that. What else can I learn? And that really gives you a really nice, easy access point. So at this point in the observing, we're just trying to grab that interest, learn a little bit about it, and use that to kickstart the project. So the next part, the next thing that we're looking at is the brainstorm. So the brainstorm is really all about thinking about that challenge, or thinking about the topic, or thinking about whatever it is you want to learn about, and starting to form some ideas about it. At some levels, this could be making a hypothesis. At the primary level, maybe it's just hearing a story, about this topic and learning more from that, or going for a walk and seeing the world around you to get some ideas. And it also is an opportunity to share what you already know. So that earlier learning that we talked about, you can use that here and say, all right, well, what do we know about this? What can we talk about? And that's the goal of the brainstorming, is really to take this early stage, to learn more about it, to get more of an idea, and then to make a guess or make a thought or an initial prediction as to, what's going on here? What do I need to know? And what can I tell you about it? So that's what we're really looking for in that brainstorm, is being able to learn more about it and to start to formulate some ideas about this topic, whatever that topic might be. So that brings us to my favorite stage personally, is the create stage. So you've thought about this challenge a little bit, you've started to form some ideas. Well, the create stage is all about taking those ideas and taking that curiosity and turning it into action. So this can take a ton of different forms. It could be a drawing, it could be building a prototype or something. It could be completing a science experiment. I like that part. That's a lot of fun. It could be anything. You can do anything you want in this stage, but it's really about taking all these ideas swirling around in your brain and showing it to the world. And that's the beauty of the create stage, is it's sharing something. So the next step after that is the improve step. And this is all about, okay, I've put something down, I've created this thing, how can I make it better? That is the beauty of science, is that there's always ways to improve it. Even if the experiment works 95% of the time, well, why not 100%? Why don't I try to improve and change things? And to do that, a really great way to improve on what you have done is get feedback. Get feedback from your family, from your parents, from your friends, from your teacher, from fellow colleagues, whoever it is. They can give you a different perspective, give some ideas, and wait a minute, I can come up with an even better solution, a deeper solution with more knowledge stuffed inside of there. And finally is the share section. This is really all about taking everything you've done and communicating it. So this is really an excellent opportunity to promote those literacy skills as well as those communication skills, and also just to reflect on what you've done, to really kind of build onto that learning using what we already know, and then thinking, okay, what are my next steps? Where can I go from that? And because we're Science North and we're doing this from home and we want to see what we're doing, we're going to ask you to share everything that you do with us. We have some great social media platforms, and we want to be able to share what you did with the world as well. So if you made something great coming out of this, we're going to ask you to share it at Science North and using the hashtag Science at Home, and we will do our best to help share all these amazing things that you've done. All right, so those are the 5 stages, and in the next part of the video, we're going to look at what those 5 stages are and how they interact and how they work with an actual project. So, because right now, I mean, it's kind of just this vague concept, but we're going to bring it in a little bit with an activity that you can do. And in all this, I haven't really talked about the teacher at all, because it's so focused on the students, and that's what this is. It's student-focused learning, where the students have that initiative on themselves, but the teachers also play a big role in it. You play a big role in this, and that is really to encourage students to learn something, to provide them with a platform and provide them with that guidance, that introduction to it. And you can also really emphasize the importance of inquiry-based learning and build that culture where that is an okay thing, is to learn and to explore and to maybe make mistakes and maybe get off track and go into the steep hole into something else. But that's okay. You want to support that. You want to support discussions. And you just want to promote that nature of science where you're learning, you're getting steps, you're promoting all of these wonderful things that we talked about. That's your role. That's what you're doing as a teacher. You can provide information, you can provide resources. So especially at the primary level, where you're not going to be asking your students to go online and research everything, but maybe you can provide their parents with some really great video links or some website links, some book recommendations, or other resources that they can use. And finally, this is also an opportunity for you as the teacher to facilitate collaboration. Maybe you want them to do this in a group. Have 2 students work on a project, or 3 or 4, or your entire class. It's up to you. You can do whatever you want to facilitate that, but that is your role, right? Your role is to promote this style of learning, to encourage your students to use it, and to really embrace it and give them the opportunity to learn from that. All right, so that's really all I want to talk about on the inquiry-based learning, what it is. And I'm excited now because that means we're going to look at a couple activities that use this that you can do with your students while they're at home and you're at home and everybody's at home. So let's take a look at those. All right, let's take a look at that activity, that first activity that we're talking about. And this one is called the mystery shape. What does that mean? Why did I call it a mystery shape? Well, that's because it is. It is a mystery shape. So what I've got here is this seemingly boring piece of cardboard. It's really not a lot to it. It's just a piece of cardboard. But on the underside of this is a shape. I'm not going to tell you what it is, and you probably shouldn't be telling your students what it is either. But maybe you want their parents to get this one set up. But having this mystery shape on the other side lets us use the inquiry-based process to learn more about it and to also follow those steps. So to give you a bit of an idea, a bit of a hint, I cut out a shape using craft foam. I did it twice to make it a little thicker. I glued it to the other side of this, and the goal of this activity is to predict and determine what you think that shape is. What is the mystery shape? There's your challenge. Figure it out. And that's all there is to it. But it really promotes that 5 steps of inquiry-based learning. So the first thing that you'd want to do is have that shape flat on the table, and we'll start to observe. All right, so we've got this shape, and the first thing that we want to do is observe. What do we see? What shape could it be? What's it made of? What do we know about this? And we probably don't know a lot just by looking at it, because it's really just a piece of cardboard on a table that's slightly elevated. But that's kind of the nice thing about this, is that it gives the students a chance to look at it, start to try to figure things out and go, how can I learn? How can I figure out what that shape is? Maybe I want to look at the materials. Okay, it's got cardboard on top. When I push on it, it's kind of spongy. Interesting. Okay. But then there's, how am I going to figure out what's underneath? Well, there's lots of ways you can do that without peeking. There's no peeking in this. No looking. Maybe I want to use a ruler to poke underneath and take a look. Feel for the sides. Feel for the corners. Ruler's not cutting it for you. Well, maybe you want to use a piece of spaghetti or something to poke and prod and try to figure out what it could be. And by poking and prodding, you can start to think about, well, do I feel any sides? And if so, how many sides do I feel? Do I feel any corners? If so, how many corners? Can I determine how long the sides are? Well, probably using, some guesses and making some predictions by prodding around and poking around. Yeah, I can probably figure out what shape this might be, or at least start to think about it. So that's the observe stage, is just that initial, well, I've got a problem. What do I know about it? What can I learn about it? And where am I going to go with this? What information can I gather just by observing? So the next thing that you'd want to do is the brainstorm process. So the brainstorm is where you take all these thoughts, put it on some paper, and think, okay, what do I got? So for this one, it's a really easy brainstorm process. Get the students to draw what shape they think it is. Do you think it's a triangle? Draw a triangle. Do you think it's a square? Okay, let's put that. Maybe it's a rectangle. Maybe you knew there were 4 sides. Maybe it's one or the other. I don't know. But that's the beauty of it, is that you don't need to know. It's all about making that prediction and then discussing why. Why did I think that? Why did I draw that? And as a teacher, this is an opportunity to maybe talk about the shapes. Well, I thought there were 4 sides, so it must be a square. Well, are there other shapes with 4 sides? I don't know. There are. But that is the point. That is what we want. We want those discussions, and you want those discussions with your students as well. So the next stage would be the create. We talked about that create step. So to create for this one, it's really quite simple. What you're going to do is recreate this project, this shape, using craft foam and cardboard. And you're going to do the exact same thing that I presented you with, or your parents or your teacher or whoever built this presented you with, and you're going to recreate it. And then that brings us really nicely to the improve stage. So to improve it, What we're looking for is, well, I'm going to compare the original that I built to this new one that I built. I'm going to use my ruler, or I'm going to use my piece of spaghetti or my pencil or whatever I need to learn more about it and see, well, is that the same? Is it different? Could it be better? Well, I thought it was 4 sides, but as I feel around, this one maybe has more sides and this one has less. How can I improve? How can I change my model? So that's the improve. And finally is the share. So now let's talk about it. Why did I build the shape that I did? Could it have been another shape? And what materials did I do? What steps did I use? So it's all about talking about it and sharing that process that you used. So at the end of the day, you probably, if we're following that proper scientific procedure, you don't have to look at the shape. I'm not going to say you can't, you don't have to. And the reason you would do that is in science, scientists don't know what the answer is. They can't see, they can't look under the piece of cardboard and like, yes, that is exactly what I was looking for. They don't always have that opportunity, but they make these predictions, they make their hypothesis, they make their guesses, they test it, and then they test it, and they test it, and they can come up with as good a solution as they can. And for that solution, well, we're going to have to be content with it. We're going to be happy for it because we went through these steps and we learned in doing that, right? So that said, if you do want to look underneath, you can do it for the sake of today. So I had a triangle underneath, and in taking those steps, I can maybe explore what that is, and maybe I want to talk about some other types of triangle. Isn't it? What kind of triangle is this? A right angle triangle? I don't know. Those are things to talk about when you're doing this project, or if you use a different shape. And for yourself as a teacher, and for the parents that you're going to be doing this with, get them to cut out maybe multiple of these, and then you can predict on a bunch of them. But it's really an activity that gets you thinking about that, the scientific inquiry process, and also a nice kind of talk about math and shapes and geometry as well. So that's what we're looking for on that activity. It's a pretty straightforward one that you can really easily do at home. I mean, I'm no artist by any means, and I was able to do it, so I'm sure that you can too. And if you do this activity, share it with us. Show us some pictures. Let us know that you're doing it. We'd love to see that using social media as well. And hopefully this is something that you can use with your students when they're at home. All right, that brings us into the third part of the video, which is that at-home science challenge. So what we're looking for here is we're going to give you a challenge, and we want you and your students and everyone involved to be able to come up with a solution to this challenge, and whatever it may be. So here it is, drum roll, invisible drums. The challenge for you is to create your very own animal based on what you know about living things. So a brand new animal, a hybrid of animals, but we want you to think about living things and create your own animal. So to take this concept and take this idea and look at those inquiry phases, the first one being the observe phase, well, there is a ton to think about in this. This is a very open-ended challenge, and well, that's what we want. We want it open-ended so you can learn, but it is super open-ended so that there's tons of things to think about. So some things to consider would be, well, what does my animal need to live? Well, shelter, food, water, those are all things to consider. What about for energy? How's it going to get that? Well, it's got to eat. It's got to drink something. Where's it getting its water? What kind of food is it going to eat? Is it a carnivore, a herbivore, an omnivore? What are those? Well, what do they eat? Something to think about. How do seasons affect it? Well, we know that there are different seasons, and well, does it change its color? Does it have to hibernate? I don't know. It's your animal. You're going to tell me. How does it grow? What do its young look like? Do they have a different name? What do they eat when they're babies? Do they eat worms? Well, I don't know. Maybe. How does it move? Does it walk? Does it swim? Does it fly? Does it do all of those together? Maybe. Could do those. And then where does it live? Does it live in Sudbury? Does it live where you are? Does it live in the ocean? Does it live in space? Did you create space animals? Oh, that would be cool. Space animals. I'd enjoy that. But that's the beauty of this project, is it can be anything you want, but you want to think about that. So for myself, I am a big fan of sharks and wolves. Those are my two favorite animals. Don't ask me why they are. So I'm thinking I want to do a hybrid of those in some sort. So I'm going to start to think, well, where do sharks live? Well, they're underwater. Okay, what can I learn about animals that live underwater? How do they breathe underwater? Well, I better figure that out so that my animal can breathe underwater. Well, they're both carnivores too. Sharks and wolves are both carnivores, so that's cool. Well, what do carnivores eat? And then I'm going to start to think, well, how do they move? A shark swims, but a wolf walks. So how is my hybrid animal going to go? Or how's my brand new one going to go? But the observe stage is all about taking that world around you, learning about it, and using that to make an informed kind of guess or an informed creation that takes all those aspects and brings it together. So the next part is the brainstorm. This is really all about taking all those thoughts and putting it into something. So for myself, that brainstorm was really all about, well, I want to draw it. And I think that is really for your students as well, or for all of you watching that's the perfect next step is to draw your animal. So I talked about my hybrid animal. I called it the sea wolf. Cha, there it is. Half shark, half wolf, all awesome. And that's my sea wolf. So I'm going to take that there and take a look at it. And I labeled it. Well, I said it needs gills. It's got some super hearing. It's got fins to make it go faster. That's what I assume it's for. But that's that brainstorm. Draw it. Draw what you think it is. Label it. Do some sketches and start to think what that is. Which brings us to the create stage. The create stage is also super awesome because you got to build it. You got to take all these ideas and bring it to life. So for myself, I did do that. What can you build? Well, you can build the actual animal itself. You can build its habitats. Maybe you want to draw what its young look like. Maybe you want to show its whole world. Maybe you want to recreate it. You can do anything. So for myself, I made a model of my sea wolf. Nom, 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 nom. Sea wolf. Bloop. And I also made its home. So when I thought about this home, well, I knew that wolves live in dens, so I made it kind of den-like. But it's also underwater, so it's got some seaweed. Maybe it's using that for camouflage and to hide. And this is where the sea wolf lives, is in its little den. And here it is. The perfect combo. But you can make anything you want for this, and we want to see that. We want to see your creative juices flowing so that we can see what is your animal and what does it look like? Where does it live? What are all these things? I want to know. Finally, the next step is the improve step. So the improve is taking your discovery, your creation, and sharing it with other people. So for myself, maybe I want to look at my sea wolf and show it to my dog, and he'll be like, "Oh, well, Brandon, that the ears need to be way bigger, more like mine." And maybe that's a change I want to make. Or you can talk to your friends, you can talk to your parents, you can talk to really anybody about this, and maybe they have ideas as to what are some cool things that your animal could have. And you can incorporate that, make some changes, and then finally, for real this time, is the last stage, is the share. Share with us on social media. We want to see what you built. We love that. We want to hear you talk about it. We want to know what you did. And what we're going to do at Science North is we're going to take all our favorites, really as many video submissions as we can, and we're going to use our social media to share it. So really a great way to promote your amazing project, to promote your amazing class, promote your amazing school, and all the cool things that you're doing. So we want to do it for you. We want to be able to share what you're doing, and we want to see what you're doing. So use the hashtag Science at Home and use the contact information at Science North, and we will be sure to share as many of these as we can, and we want you to share them with us. So that is the challenge. Create your own animal, go through those steps, and then let us know what you did. With that, that's really it for me today. So thanks for coming out. Thanks for participating with me today. I hope you enjoyed it as much as I did. My name is Brendan, and I will see you very shortly for another video. The next one that we're going to do is we're going to look at inquiry-based learning at the junior level. So we'll see you soon for that. Thanks for coming out, and I hope you have a good day. Bye.